irrigate in the evening through early morning hours. This is particularly true for sprinkler irrigation systems because less water is lost through evaporation and more water is available to infiltrate the soil. Also, many municipalities have instituted water use regulations that limit use to evenings and early morning hours. In situations where foliar diseases are a problem, it is important to avoid irrigation systems that keep moisture and humidity around the leaves for extended periods of time. Water should be distributed uniformly to as much of the root system as possible. If only part of the root system can be watered, such as when hardscape covers the soil surface, supplying water to accessible parts of the root system is better than not irrigating. In any case, efforts should be made to keep the root collar dry between irrigations. Maintaining wet soil in contact with the lower trunk, root collar, can lead to infection by soil-borne pathogens. Although various methods can be used to water landscape plants, sprinkler or drip systems are most common. Both systems have advantages and disadvantages, however. Well-designed and maintained sprinkler systems can apply water effectively and efficiently. Appropriate valving, pipe sizing, and head selection and spacing are important considerations in system design. System monitoring, including head cleaning and repair, is needed to ensure continued effective operation. Although sprinkler systems can apply water uniformly across the root zone of a tree, they also can apply large quantities over short periods of time, leading to water runoff and erosion. Limiting application times to match infiltration rates and climatic conditions, and using low application heads can minimize this problem. Another potential concern is that sprinkler irrigation can lead to crusting of the top layer of soil, especially when applied to bare soil. Drip irrigation systems apply water slowly to localized areas of the tree root zone, reducing the potential for runoff, erosion, and water loss by evaporation. Emitters, end-of-line or in-line, should be spread out over the entire root zone and kept away from tree trunks. To apply water to the expanding root system of young trees, emitters should be moved away from the trunk and additional units may be required. It is important to recognize that emitters can become plugged and lines damaged. Sometimes the only sign of a plugged emitter or broken line is a water-stressed plant. Frequent monitoring of drip systems is critical. Other methods to irrigate trees include high-pressure water injection, soaker hoses, basin irrigation, and temporary portable drip systems. Portable drip or soaker systems can serve as an effective means of supplying water to newly planted trees, to transplanted trees, and to established trees during periods of drought. Basin irrigation is useful for newly planted trees, distributing water uniformly to the limited root zone. High-pressure water injection can deliver water deep to the root zone, but may bypass many of the absorbing roots at the soil surface. Soaker hoses are portable and can apply water slowly where runoff may be of concern. Many irrigation systems are designed and installed primarily to irrigate turf and other landscape plantings. Too often, trees are not properly considered in irrigation management programs. Excessive irrigation of trees is becoming a problem in many parts of the United States. Fungal problems such as root and or collar rot are often associated with excessive irrigation. These conditions are particularly troublesome in instances where irrigation is applied directly on the trunks of trees. Tree species that are adapted to dry summers and native to such climates are prone to problems associated with frequent irrigation. Often, tree root systems are damaged during the installation of below-ground irrigation systems. Roots can be easily cut when trenches are used. Damage to roots can be minimized by proper system design and by using pneumatic air tools rather than mechanical trenchers to dig irrigation trenches. Water is a very limited resource in many areas, and water conservation needs to be considered as an integral part of water management programs. Although irrigation requirements for trees are generally much less than those for other types of landscape plants, such as turf, in some instances, irrigation may be necessary to maintain tree health. Minimum irrigation provides only that amount of water needed to maintain tree health, growth, and appearance, canopy density, and leaf color, using efficient application methods. When planning a new landscape where minimum irrigation is to be used, plants with similar water requirements should be grouped together and irrigated on the same schedule. This technique usually employs the use of plants with low water requirements and highly efficient irrigation methods. Keep in mind that new plantings require more frequent waterings until they develop established root systems. Also, caution is in order when transitioning to minimum irrigation because plants must adapt to lower soil moisture conditions. Minimum irrigation practices require an understanding of water budgets, plant and soil water loss, evapotranspiration, ET, water holding capacity, application rate, infiltration rate, and irrigation system efficiency. Evapotranspiration is measured in many locations and is used to estimate water loss from agricultural crops and turf grasses. This information has been adapted for trees and other landscape plants. Charts of average ET are often available in the United States and other countries through cooperative extension or agricultural department offices. Minimum irrigation combines water loss information with the amount of water available in the soil to determine appropriate irrigation schedules. Another approach to minimum irrigation employs soil moisture monitoring. Devices such as tensiometers and electronic moisture sensors are used to measure soil wetness or dryness. Carefully tracking soil moisture before and after irrigations allows the amount of available water to be assessed in order to adjust irrigation recommendations. Arborists and other professionals may be called on for advice when irrigation systems are being designed, installed, or adjusted. An understanding of the water requirements of trees and other plants in the landscape is an essential part of estimating how much water will be needed and at what frequency. Information regarding ET, water holding capacity, irrigation efficiency, infiltration, and application rates needs to be put together so that an appropriate watering schedule can be developed. The water source for irrigation affects the quality of the water. As water flows over or through soil and rock, mineral salts dissolve and are carried up by the water. Excess salts in the water can be detrimental or even toxic to plants. Recycled water can be high in salts as well as other chemicals. These chemicals can raise the soil pH, increase soil salinity, cause problems with phytotoxicity, and clog irrigation nozzles. Recycled water can also be high in essential elements such as nitrogen, phosphorus, and sulfur. For example, irrigation water taken from landscape retention ponds can have high levels of sodium and chloride salts. This is especially true where parking lot runoff is captured. If this water is sprayed on foliage, severe leaf scorch can result. The pattern of scorch on the tree canopy will coincide with the arc of the irrigation spray pattern. The success rate in using recycled water depends mostly on the soil type, water quality, and sensitivity of the plants to salts. Because good drainage is essential, sandy soils usually work better. More frequent irrigation is usually necessary because drought stress will occur at higher soil moisture content under saline conditions. It is important to monitor plant health and soil conditions frequently when irrigating with recycled water. Efforts to select salt-tolerant plants, halophytes, can reduce the impact of saline water sources on the overall health of the landscape. With sprinkler irrigation, less frequent irrigations of longer duration will lessen the likelihood of salt buildup. If irrigation water does not penetrate the soil deeply, most of the salt brought in by that water will remain near the surface. Under saline conditions, irrigation may need to be provided more frequently. Soil damage can result from excessive sodium in irrigation water. The amount of water found within the soil is constantly changing. Plant available water increases as water enters the soil through precipitation and irrigation and decreases as moisture is lost through evapotranspiration. The net gain or loss of water in a given day is the daily balance. In order to gauge the current level of plant available water, the daily balance is either added or subtracted from the previous day's plant available water level.